Well, hi, and thanks for joining me here in my shop near the shores of Lake Couchiching in Ontario. So what we're going to be doing is I'm going to try and fire up this power supply. My last video ended with me a little bit frustrated, but frankly, within 10-15 minutes of finishing that video, I realized what these wires were for and how I can power this guy up. So that's what I intend on doing. Again, the radio itself, you can kind of see some of it back here, is not quite ready to actually be operated. It needs a little bit of work. I have to put a rheostat back on it, and I'm waiting for the front panel to arrive at my house. I can put the front panel back on, put the whole thing back together, but in the meantime, I could give this guy the once over here, especially now that I understand what these little green wires were. So in the last video, when I was looking at the gargantuan connector here, I noticed that there's more of these than there are screws to attach to. And I noticed the last two were painted green. Somehow I couldn't get enough brain cells connecting here at that time to realize, well, these two wires, which are looking for a place to go, are also colored green. So the synapses finally made some contact with each other about 15 minutes after the video. So now I realize these, which would connect to those terminals right over these two in this area where it says SWSW, which has to be switched. I mean, it all makes sense. So I think all I got to do is just short these two together. It's just like closing the switch. This thing will come on, the tube should light up, and I should get some high voltage here, which is really what I'm looking for. So let's see here. So this is ground. As most of you would know, but some of you won't, this is the brand new shop. It's not really fully outfitted, and I may have trouble finding the simplest of things here for a while, such as clip leads. Clip leads. Clip leads. Somebody show me a couple of clip leads. Okay, can't spot my clip leads. How about a screwdriver? Oh my gosh. Now it's mid-October here. It's mid-October everywhere, isn't it? Not just here. And I have moved a little ways north and west of where I was. And I'm now in what's known as the snow belt in Ontario. That's another way of saying a lot of snow falls here in the winter. There we go. I was listening to the weather report on the radio this morning, and I heard the word snow go by a few times. I don't think it's right here. It's not far away. Oh my gosh, snow in October. I don't know. Maybe I should pack up and move back to where I was. So I'd gone from living 1 kilometer from the shoreline of Lake Ontario, which is a gigantic lake. It's one of the Great Lakes. It's gigantic. To a couple hundred meters from the shore of what you might call a medium-sized lake, but it's much, much smaller than Lake Ontario. And Lake Ontario is so big it wouldn't affect the weather. Keeps you a little warm in the winter, keeps you cool in the spring. It's very significant in the spring. Now, let me think for a minute. Hold on, stop talking and start thinking here a little bit. So I don't electrocute myself here. Be off to a bad start. Now, I shouldn't be able to electrocute myself. My shop is running on isolation transformers, so I can still get a shock. There's lots of ways to get a shock, even under those conditions. But I can't get it through my feet into the floor. if I'm grounded. So power's off, we'll plug it in. Now there was a switch here which just says 120 and 110. So I'm going to leave it on the 120 side. The line voltage today is running around 117, 116, 117 according to that meter. And because all this is fairly new, new to me too, this meter is going to show the voltage rate on the end of this plug that I have the power supply plugged into. Okay, let's say we're ready to go. The thing is, we want to keep our eyeballs on this light here. This one is screwed in, this other one is just loose. It's not connected. So all the power that's coming out of the from the power company that's reaching this is passing through this light bulb, which I've explained many times. That should keep me safe. As usual, I'm hesitant. All I got to do is short these two things together here. Okay, power. So maybe I just kind of plug these together. They might just happen to work that way. I'm lucky. Huh. There we go. Okay, just make sure they don't go where I don't want them to go. I could start this up with the plug with the tube out, but I don't really see the need or particular advantage of that. But it would be one way to start this up with even less stuff going on in it. I have not tested this tube, but it's nice and clean. Okay, let's put the power on here and see what happens. I think from this camera you can still see the meters clear enough. There we go. Okay. So I'm expecting this meter to show up something around 190 volts. I've got it on the 200 volt scale. I think I'll put it up on the 1000 volt scale in case it goes a little over 200. Yeah, but the big thing to watch initially is this light bulb. Here we go. Okay, is anything happening? The tube is warming up. Whoa! 400 volts. 450. Holy smokes. How's that for a surprise? 450. Come on, is that for real? Holy smokes. Okay, so on the panel here, somebody's written 195. Or did they write 395? No, it's 195. Well, let's see. Where would they get those numbers from? They probably got those numbers. Well, they could have done a test just like me. Let's call it an open circuit, no load test. Or they had the radio connected and they took readings with the radio drawing power off this. That's awfully high. I mean, I have a light bulb in series with this thing too. So now the light is not glowing at all. Let's take a closer look at that. No, there's no glow. There's no glow in the light. The line voltage is coming out around the same. Both of those line voltage meters are reading about the same. So there you are, and it's perfectly stable at 450. Wow. Man. So if you put a load on this, it might come way down. This next one's supposed to be 125. Next one's supposed to be 47. Oh my gosh. At least that's what it says. That's no 47. The next one's 180. They're all 450. Okay, so here's some AC, AC, and AC. I have to read those differently. Oh my gosh. For all I know, these numbers are completely bogus. And 450 is the intended voltage. Because, you know, it's got this little nameplate on here, but it doesn't actually say what its output voltage is. Of course, there's a whole bunch of them here, so you'd have to list it all some way. What if I flip that switch from 120 to 110? It should go up. It should go up in voltage. So I don't think I'm going to do that. I don't really feel like throwing that switch with it operating. Well, let's check these AC voltages here. Let's see what we get. No funny sounds, no funny smells coming out of this. Okay, so there's 5.7. That's supposed to be 5. That's pretty good. This is supposed to be 2.5. Okay, it's a little high. 3, and this is supposed to be 1.5. What's going on there? Okay, 1.8. I think the 1.5 is heater. Supplies heaters. I would guess all these supply heaters. There must be a couple different voltage rating of heaters of tubes in here in this radio, I guess. Wow, 450 volts. That's kind of the limit of, I think, this tube even. And I'd whip open my tube manual and quickly check it, but I don't know where it is just yet. So I don't think we need to do anything more here. I would put this on a scope. I could put this on a scope, and we could look at the waveform and see if it's nice, even DC, but doing that in the open circuit test isn't all that meaningful. It's probably going to show up just fine. Really nice DC at 450 volts. If you put a load on this, for all I know, it drops all the way down to 195, and it may even introduce a little bit of chop or hum into it once the load is put on it. Suppose I could stick a resistor on here and fake the radio, but I have no idea what resistor I would use. You know, what's the resistance of the radio? I don't really know. Offhand, I can't whip out an ohm meter and just measure it. I don't think it's that easy. Or did I do something wrong here in shorting out these terminals, which are a little hard to spot now in the camera, but they're right there, the two green lugs. It's a little late, but maybe I should trace back the switch wire over here. Let's turn this off. Let's turn this off before I stick my elbow on the 450 volts here. By the way, this thing just weighs a ton. Okay, so let's see, here's the switch. The switch is on wires that go right into this cable. So I don't think there's any doubt. This switch does nothing more than connect those wires together, which I'm going to disconnect. Huh, how do you like that? Well, a bit of a short video, but there's really not much else I can do at this point. So I think we're going to set this guy aside. I mean, this basically is good news. It's not a bad news test. It's a good news test. This thing is producing an output. All the terminals are live, so it didn't do anything funny. It's still cold as ice. And tube appears to be working. So I think that's about as far as we can go with this radio. I'm going to have to bring another one out and set this one aside, like I said, until some stuff shows up in the mail. Hey, I haven't checked the mail for 2 days. I better go out and take a look. Maybe it's out there. Huh. I'll go do that right now. Hey, thanks for watching so far. Well, I did not find anything out in the mailbox except for 2 newspapers, but I did find this. Let's take a look. Now, I had a wasp nest at my front door, and I think, I'm not sure. I think this might be the queen bee. I don't think so. I don't think queen bees come out. Poor guy's long dead. Hopefully, he had a good summer, had a good life. Look at that. Is that a schnoz on that thing? What's he got there? Might be a lot more fun looking at it under the microscope. Oh well. There he is. Not quite a cat video. A dead bee video. Pretty furry guy, eh? Look at that. Wow. Anyway, maybe my bee problems are over, so we'll catch you on the next video, and thanks again for watching. Okay, I just couldn't resist. I don't want to see what this guy looks like under a microscope, so there he is. Let's take a look and see what we can see here. Now, I have not got a very good microscope here. I mean, it's a good one, but it's in bad shape. Let's see what we can. Oh, look at that! Check that out. It's gotta be his one of his legs or something like that. No, you know what? I think that's an antenna. Let me move it here. See if we can't find our way out to the end. Like a wrist or joint of some sort there. I guess all those sections are a little bit joint. Let me just move it this way. Oh, that's his furry little body, so we're looking at the wrong end of it. Let's go out here. Oop, go out to the business end. There it is. Wow, you can't do much. So this is this I'm sure is his antenna. Nothing special going on at the end of it here. Let's take a look at his head here. Okay, so I'm looking down at his head. Let's go up. And, I'm having some trouble getting up high enough to focus. Oh! I've just reached the end of my focal position, but check out what's coming in there. That's got to be his compound eye there. You know, from what little I know about compound eyes, it just seems to me impossible that you could have a compound eye and fly successfully with it. Boy, it's very confusing moving this around on the slide here. I don't know what I got there. I gotta lower him down. He's up too high for my microscope. Let's see if I can. I do have a slide here, but it's got all kinds of needles taped to it, but I think I can stick them here. Oh, you're not still alive, are you? Frankly, I've seen this guy laying outside for a few days now, so I'm sure it's not alive. Okay. Whoa! That's a little better. Let's see if we can find that eyeball. You see, as an adult, I get to do all the stuff I wanted to do as a kid. I think I'm on the lowest magnification. I may not be. You know what? I think there's a lower magnification here. Ah, that's a little better. Well, it's easy to have too high a magnification. Is that his proboscis? Yeah, so I was saying the compound compound eye. I just can't believe that you can really see accurately. I guess the way to put it is that it provides enough information into their little tiny brains that they can make correct choices about what to eat, where to go, and who to stay clear of, and where does eyeball go? He's closed his eyes. That's what's happened here. Okay, you can think of compound eye as forgetting the scale for a minute. If you took a whole bunch of cardboard tubes, like the paper towel tubes, you know, considering the size of our eyeball, so a whole bunch of cardboard tubes like that, and kind of put them all together into a bundle, and then somehow bent the bundle so that each tube is looking in a slightly different direction. And then you put, don't look through the tube, put some paper towel across all the openings at the eye end, if I can call it that. I can't find his eyeball. I guess it's not a ball, is it? It's not an eyeball. Anyway, you put some paper over the end of all these tubes, and then look at the paper, and it's a binary thing. If the light comes down through the tube and hits the paper glows a little bit, and you can identify which tube is pointed directly at a light by the kind of glow on this piece of paper. Come on. That's about how a compound eye works, with hundreds of those tubes. So the animal can tell there's light in the direction of any particular tube, but I don't know if it can generate an image of that like we have in our heads. There, I think that's it there. Yeah, I think that's it there. Let's see, I just there. That's pretty centered. Yeah, that's got to be it. So behind each one of those little facets is kind of like a tube going down, or something of some fashion like that. And now I can go back up on the higher power. I mean, we've all seen these things in school and whatnot. Yeah, in the lower right part of the image, you get a really nice look at it. Fantastically organized it all is. I guess the whole animal is organized, isn't it? You know, our shape of our bones, and it's not random at all, but isn't that something? Yeah, I think the last thing to take a peek at is one of his feet. feet are sticking up because he's on his back. So again, I may not be able to raise. Oh, I may not be able to raise this high enough to get a look at a foot. Let me raise it all the way up. Oh, there we are. Oh. Okay, it's not his whole foot. I'm not exactly sure what's happening there. That looks like the very tip on the right hand side there. And then it looks like it comes back, a little hooky claw thing there. It looks like it comes almost like into a receptacle or a joint of some sort. Now let me take the down here, a little less power. Oh, there's two of them there. Okay, so he's got like tweezers and little hairs. I bet you those hairs are more for sensing. They give him a better idea of what it is he's trying to grab onto. It's like a foot up at the top there, I guess would be like an ankle joint, sort of. I mean, obviously they aren't built like us. They don't have ankles, stuff like that. But one of the things I love about doing this is it opens your eyes to just how detailed and complex things are at a level you can't even see with your eye. Yeah, look at that. Like multiple joints, if that's what that is. I think that's a joint. You can't tell me, at least I can't hear you. I know nothing about biology. That's probably pretty apparent by this point. Oh, look at that wicked looking thing. Come on. It's very confusing moving this. There. I can see my fingers off. There we are. Ah, it's a lovely view. Check that out. I just saw something on the TV that said a fish's eyes are like our eyes, are curved enough that it allows them to see things at a microscopic level, such as, I think it was protozoa, would that be the right word? Stuff in the water that it likes to eat that we can't see, but it has to see to find them. Yeah, that's really, it's lots of little hairs there again. I bet you they're mostly for sensing. Wow. There's that little orange ball there. Right just about dead center where one of his claws come back. It could just be looks like a bunch of little orange things there. Well, I'm not going to get into the structure of a bee. Hey, one more thing. Let's check out his wing. Yeah, sure. No microscopic examination of an insect is complete without its wing. Whoop! I just bumped it here. There's the wing. Yeah, it looks like it's full of pores, doesn't it? I'm not sure what you would. Of course, this is the wing of a dead animal, so it may not be anatomically normal anymore. Just amazing they can pack all that in such a little animal. You know, because this is a flying animal, right? It flies around in 3 dimensions. It goes long distances, finds its way back, flies back into its nest. There's just a little entryway. It knows exactly where to fly to. If you watch them, they're like planes landing on an aircraft carrier. They just come right in, boom. Well, you know, we don't think anything of it, right? We don't find this stuff amazing normally. It's all, but it is. It's really, really, really amazing. It's more amazing than these old radios I look at. Only problem is I'm not going to bring this guy back to life. Yeah, we could try to look at his business end. I don't think this guy's got a stinger, because it's a queen, or it's some kind of special bee. If it's not a queen, it's still a special bee. You know, maybe it's just a bumblebee. That is its business end right there. Wow. That's its rear end. Maybe it's not too much business going on down here. Okay, enough bee looking. Couldn't resist. So, we'll catch you on the next video. See ya.